Today we're going to look at section 2.4b. We're continuing to work with linear equations, but our focus today will be on parallel and perpendicular lines and writing equations for those. But before we start that, we are going to go back and do a little review from yesterday. The first example says the office manager of a small office ordered 140 packs of printer paper. Based on average daily use, she knows that the paper will last about 80 days. What is the equation for a line in standard form? Now notice they're giving you the final version, but that doesn't mean we have to start with that format. So what we're told is at the beginning she orders 140 packs. So basically on day 0, when we're starting this, at day 0 we have 140 packs. At day 80 we should be all using them all up. So we would be down to 0 packs left. So we're given 2 points. They've just hidden it a little bit in a word problem. So our first step is going to be to find the slope. So we do change in y, so 0 minus 140, divided by a change in x, 80 minus 0, which gets us negative 140 divided by 80. And that reduces down to, we can divide both of those by 20, so negative 7/4. That is our slope. We're going to go ahead and put it in point slope form. So y minus, let's go ahead and use our first point here, y minus 140 equals our slope times x minus our x coordinate. So if we distribute the negative 7/4 to x minus 0, we get negative 7/4 x minus 0. 0 times anything is 0. Okay, let's add the 140 to the other side. So now we have y equals negative 7/4 x plus 140. And then that is in slope-intercept form, but they asked us to put it in standard form. So standard form, we'd want to get the x and y's all on the same side. So I'm going to go ahead and add my 7/4 x over to the left. So now I have 7/4 x plus y equals 140. And then remember, standard form, we want to get rid of any fractions. So we're going to go ahead and multiply everything by a 4. So we'd get 7x plus 4y. And then 4 times 140 would be 560. So this is standard form, where x and y are on one side. This is slope-intercept. And we started with point slope. So quick review of all of the different versions that we had in our lesson yesterday. All right. The second part says, how many packs of paper should the manager expect to have after 30 days? Our easiest version of all of the three that we had is our slope-intercept one right here. Sorry. So we have y equals negative 7/4 x plus 140. And they're telling us that we're looking at how much do we have after 30 days. And remember, we had x representing our days, so we're going to plug a 30 in for x. If we take negative 7/4 times 30, we get negative 5250 plus 140 ends up getting us 8750. So we would have about 87.5 packs of paper left after 30 days. All right, let's look at a second example. It says the cost of a taxi ride depends on the distance traveled. So cost is dependent on distance. It says you paid $8.50 for a 3-mile ride, while your friend paid $18.50 for an 8-mile ride. What graph models the situation? So they have told us that cost depends on the distance we've traveled. So we're going to have our distance be our x-coordinate, and our cost is dependent on that x, that is our y-coordinate. They're actually giving us two ordered pairs here, 2 points for our graph. We are told that our distance is 3 miles and it costs $8.50. And when our distance is 8 miles, it costs $18.50. So let's let our distance be our x-coordinate here and cost on our y-axis. And we're just going to go by single units. So we need to, let's see, 1, 2, 3 is here. 8 would be there. And going up on our y-axis, there's 5, 10, 15 is there, and 20 is at the top. All right, so plotting our points. We want to go 3 in the x direction and 850 in our y direction. So we're going to have a dot right about there. Try to get my points to match up. And then when our distance is 8 miles, we want to be up at 1850. So right about there. And so we can connect those with a line to get an estimate here of that equation. Then it says, what is an equation for the line? Give your final answer in standard form. So again, that's the final answer, not how we were going to start. So we have 2 points. So our main process for doing this then was to find our slope. So the change in y2 minus y1 over the change in x, x2 minus x1. That gets us 1850 minus 850 would be 10, and 8 minus 3 is 5, so our slope is 2. I'll just go ahead and use the first point here. So putting this in point slope form, y minus our y-coordinate equals our slope times x minus our x-coordinate. Let's distribute. We get 2x minus 6. And then we're going to add 850 to the other side. 850 with a negative 6 would be 250. And then that's in slope-intercept form, but they're asking us to put it in standard form. So we're going to get our x's and y's on the same side. I'm going to bring the 2x to the other side by subtracting it. And then again, it's always nice in standard form to have your first term positive. So let's go ahead and multiply all of this by a negative 1 to clean it up a little. So we get a positive 2x, we get a negative y, and multiplying to that, we get a negative 250. So that is the equation for that line in standard form. Part C says, what would a 10-mile ride cost? We are given information about a 3-mile and an 8-mile ride. But let's go ahead and use our equation here, and we're looking for where x is 10. So we're just going to plug a 10 in there. So we had 2 times x plus 250, and they're asking us to find when x is 10 miles. So multiplying, we'd get 20 plus 250. So our total would be $22.50 for a 10-mile ride. All right, so the main focus for today is to look at writing equations for lines that are parallel and perpendicular. So our definition for parallel lines is that they have the same slopes but different y-intercepts. In other words, they kind of follow each other, but they never are going to cross. So if they're asking you to find an equation for a parallel line, the first thing you want to do is identify the slope of the initial line or the original line, and then you're going to use that slope in point slope formula using the new point that it needs to go through. So for example, write an equation for a line that is parallel to y equals negative 2x plus 1 and goes through the point negative 2, 5. So they're giving you this equation just so you can figure out the slope. We want to be parallel to it, so we want to have the same slope. And in our y equals mx plus b format, slope-intercept, our slope is m. So we know that our initial line has a slope of -2, and our parallel line, that's our symbol for parallel, our parallel slope is going to be the exact same thing. So we have our slope and we know a point it goes through. We want to start in point slope form, and in this case they're actually letting us stay in point slope form for our final answer. So remember, point slope looked like this. Y minus y1 equals m times x minus x sub 1. And then we're going to dump in our values. So y minus our y coordinate is 5 equals our slope here is -2, and x minus our x coordinate, which is a -2. Let's clean that up just a little bit. It said to leave it in point slope form, but we can clean up this minus a negative into just x plus 2. All right, our next example, it says line AB passes through the points 2, 3, and -1, 2. What is the equation of a line that's parallel to that? And it goes through the point 6, 3. So we are given 2 points, and all we really need to do is figure out the slope from there, because we want our line to be parallel to that one and to go through this new point. So using our initial points, our slope would be the change in y, so 2 minus 3, compared to the change in x, -1 minus 2. So our initial line has a slope of -1 divided by -3, which would be 1/3. And we know that parallel lines have the same slope. So this line that's parallel to that is going to have a slope of 1/3, and we are told it has to go through the point 6, 3. So we're going to use those values in our point slope form. So y minus our y coordinate equals our slope, 1/3, times x minus our x coordinate. Now it does say in this one to simplify it to slope-intercept form, so we'll go ahead and distribute our 1/3. 1/3 times x, 1/3 times -6 would be -2. And then slope-intercept form is where we have y equals mx plus b. So our last step here would be just to move that 3 over. We're going to add it over, and we get y equals 1/3 x plus 1. All right, that is our equation in slope-intercept form. Let's look at perpendicular lines. So perpendicular lines have slopes that cross at right angles and have the slopes are opposite and reciprocals. So they cross at right angles. The two lines are going to look like they're intersecting at a right angle, and their slopes are opposite and reciprocal. What we mean by that is opposites are opposite signs. So one is going to be positive and one is going to be negative. And reciprocals are basically like we flip the fraction. So for example, if I said my one slope, my initial line, has a slope of, say, 4/5, my perpendicular one, and our symbol for perpendicular looks like that, kind of an upside down T. So m perpendicular, our perpendicular slope would be the opposite sign. So if our initial one is positive, this will be negative. And we're going to take our 4/5 and we're going to flip it over and make it 5/4. So we're going to look just at calculating our perpendicular slopes before we start writing equations. This one says, what is the slope of the perpendicular line for each example? So our initial line in this one has a slope of 3. Our perpendicular line has to be the opposite reciprocal. So opposite sign will be negative, and then the reciprocal of 3, if you think of it as 3/1, would be 1/3. Now be careful, because if it is not in slope-intercept form, we have to convert it to that in order to find the slope. In this example, our slope here is not is not a 2. We have to convert this into slope-intercept form first. So I'm going to subtract the 2x to the other side. So we get 3y equals -2x plus 9, and then we're going to divide everything by 3. So our slope is actually -2/3. That means our perpendicular slope will be the opposite sign. Since the first one's negative, this will be positive. and 2/3 we're going to flip to 3/2. Okay, in our next example, we're given a graph, so let's look at calculating our initial slope. We can connect this point and that one, and our slope here is down 2 and over 1. So our initial slope is -2. Our perpendicular slope is going to be the opposite, so positive, and the reciprocal of 2 over 1 would be 1 over 2, 1/2. Our fourth example, we're given 2 points, so let's go ahead and calculate our slope. Change in y, so 2 minus 3, our y coordinates, over the change in x, 0 minus 4. We end up with -1 for our numerator, -4 for the denominator. That simplifies to be a 1/4. So our initial line has a slope of 1/4. Our perpendicular line would have to have a negative slope, and the reciprocal of 1/4 is 4 over 1, or just -4. All right, our last example. What is the equation of a line that is perpendicular to y equals -4x plus 2/3, and it goes through the point 8,5? This one says we can leave it in point slope form. So we want a line that's perpendicular to this. Our initial one is given in slope-intercept form, so we can look right here and find our slope. So our initial slope is -4. Our perpendicular slope will be the opposite sign, so positive, and the reciprocal of 4 would be 1 over 4. And now we want that line to go through this point 8,5 and have this slope. So y minus our y coordinate equals our slope times x minus our x coordinate. And they did say in this one we can just leave it like that in point slope form. All right, so we've gone through some examples of parallel and perpendicular lines. So let's go ahead and have you pause the video, try these next couple, and then turn it back on and check your work. It says, what is an equation for a line that's parallel to 4x plus 2y equals 7 and going through the point 4, -2? They want final answer put in slope-intercept form. So remember, parallel means same slopes. We do have to convert this into slope-intercept form. So 4x plus 2y equals 7. Slope-intercept form, we would need to subtract the 4x over. So we have 2y equals -4x plus 7, and then divide everything by 2. So we get -2x plus 7/2. So our initial line has a slope of -2. And if we want a parallel line to that, it's going to have the same slope. So we want to use that slope, and we want it to go through that point. So we're going to start with point slope form. Y minus our y coordinate, -2, equals our slope, also -2, times x minus our x coordinate of 4. Simplifying, we've got y plus 2 equals -2x plus 8 once we've distributed. And then slope-intercept form, we just need to bring our 2 to this side. So we end up with y equals -2x plus 6. All right. What is the equation for a line that is perpendicular to this one, y equals 3x plus 8, and it goes through the point 9,2? So our initial line, our original line, has a slope of 3. Our perpendicular one, remember, has to be opposite and reciprocal. So it will be a -1/3. And we want it to go through that point with that slope. So let me start with point slope form. Y minus our y coordinate equals our slope times x minus our x coordinate. Now standard form, we need to get this all the way down so that our x and y's are on one side. So I'm going to go ahead and distribute. I've got -1/3 times x, and negative 1/3 times negative 9 is a positive 3. I'm going to combine my constants, so I'm going to bring this 2 to the other side. So y equals negative 1/3 x plus 5. And then we have to get our x's to the other side. So I'm going to add 1/3 x to both sides. So I've got 1/3 x plus y equals 5. And then remember, in standard form we want to clean that up and have no fractions, so I'm going to multiply everything by 3. 3 times 1/3 is 1x. 3 times the y would be 3y, and 3 times the 5 would be 15. All right, so quick summary. Parallel lines have the same slope. So your initial slope is going to equal your parallel slope. Perpendicular lines have opposite and reciprocal. So for example, if m is 2/3, your perpendicular one is going to be negative 3/2. Okay? Opposite and reciprocal. All right. Have fun doing your assignment.